This is a question that covers both the aromatics and the carbonyls topic. There are three sections, A, B and C. Pause on the video to try each one, and then when you've done them all, move through and review, see how you've done on the remainder of the video. So here's A, here's B, and finally here's C. So if we take a look at A, we're dealing with acyl chlorides. We've got an acyl chloride here reacting with benzene. We're using AlCl3 and we're told it's electrophilic substitution. First of all, we need an equation to show how the electrophile is formed. We know that's going to be positively charged as an electrophile, and it's going to act as an electron pair acceptor. And once we've got that, we're going to outline the mechanism. So there's only 4 marks here. First one is for the equation, where the acyl chloride loses its Cl. It means that the carbon becomes positive and the AlCl3, which is our Friedel-Crafts catalyst, becomes AlCl4-. As a catalyst, it's regenerated later on, although that's not an important part of this question. For the mechanism itself, we then draw them out, as I've done here, and I draw my first curly arrow. Now remember, a curly arrow represents the movement of electrons from electron-rich to electron-deficient. So it's going to go from the delocalized ring to the delta-positive carbon. When that happens, my ring is no longer complete. It's electron deficient, so it becomes positive, but my COCH3 has bonded onto the benzene ring. As a small technical point, to get the mark on this for the structure, you have to add on a carbon adjacent to where your curly arrow has crossed the benzene. Now from there, I've now got too many bonds around that carbon. So the electrons from the CH bond that breaks move back in and regenerate the delocalized ring. The mark allocations here, we've got 1 for the equation, 1 for each arrow, and 1 for your intermediate structure. Moving on to part B, we have got here an alcohol. You're asked to name it, to give a reagent for what would make it, and what we would call that mechanism. Now, the longest carbon chain is 3, so the name is based on prop. I've got an alcohol and I've got a phenyl group, and they're both coming off the first carbon. So it becomes 1 phenyl, propan, 1 ol. In terms of the reagents, there are others which you can use, but I'm going to go down the route of hydrogenation, which is hydrogen with a nickel catalyst. You do need both of those to get that mark for the reagent. And as I've already touched on, the name of that reaction is hydrogenation. Moving on to part C, we've got the alcohol shown in part B reacting with ethanol chloride to form an ester. Describe what would be observed, name the mechanism, and draw the structure. So we're not actually doing the mechanism, so sometimes it is helpful to actually remember the mechanism names. We're going to get misty fumes of HCl. That is a standard observation with any acyl chloride when it reacts, because we're going to make HCl. In terms of the mechanism, this one is nucleophilic addition elimination. And I'm going to take a look now at the ester that we would make. I've brought the diagram over of the alcohol, and I've also drawn out the acyl chloride. And where we're going to get a break here, where the ester can form, is we're going to lose this HCl as a secondary product. And the O bonds directly to the carbon. Now, if you go through that process, it can be easy then, or easier, to visualize the ester and draw it out correctly. And it should look something like this.